this is one of the examples that we were looking at in multiple choice group 2 for the chi-squared tests. Here we're looking at a number of commercial flights and how many on-time departures they have versus the number of days that these things happen. In order for me to do the chi-squared statistic for the goodness fit test, I have to in fact get the actual expected values, and that's the challenge here. We have the observed 12, 75, and 13, but we don't know how many to expect. Out of the two days or two options, we need to kind of come up with probability. What's the probability that I would get 0 or 1 or 2? And then I can multiply those probabilities by the total sample size of the 200. So what we're going to do, it tells us that it's a binomial situation, right? So what's the probability that we could get 0 number of on-time flights? Well, they tell us the probability of success here, P, is equal to 0.8. So this is the chance. What's the probability that I missed the flight, hello Shamil, twice? So that means I would do 0.2 squared. That's going to tell me the probability of getting 0 is 0.04. The probability of missing the flight one time, remember there's two ways to do this. We can miss the flight first and then make the flight second, or, remember or is addition, or I can make the flight first and miss the flight second. When I multiply those two things together, I get 0.32, multiply and add them up. Okay, we have another option of getting two flights at the same time. This one's actually pretty easy. It's 0.8 squared, so it's gonna be 0.64. So now I have different probabilities for each of the different outcomes. To get the expected number, and you've practiced this a few times hopefully by now, we multiply the probability of that outcome happening times the sample size, and that tells me out of 200 flights, how many times would you expect to miss, 0 times or 1 time or 2 times, and that'll allow me to figure those things out. So let's do that real quick. 0.04 times 200, that's going to be 8. Then 0.32 times 200, that's going to give us 64. And then 0.64 times 200, it's going to equal to 128. So when I take these values, these are the numbers that we're going to plug into our expected cells. If we're doing this in the calculator, this is what would go into L2, right? 8, 64, and 128. I've got the observed ones already. They gave those to us at 12, 75, and 113. Remember the chi-squared statistic, which is technically what this question is asking you to calculate. It's going to be the observed minus the expected squared over the expected, right? Plus, I'm going to do that for each of the different values, right? So we're going to have 3 different fractions added together. And I'm not going to go through all the process, but you can see that there. Obviously, a couple of things you can use to really make this easy. And I'm looking for the values here to be the same. These are the expected numbers. That's what we calculated from over here, right? And then I'm looking at the observed values here, which that comes from the ones they gave us in the problem. So I can eliminate a couple really quick. If I just look at the fact that I'm supposed to have my expected counts in the denominator for all 3 of my fractions, then I'm already down to having answer A is the only possible option, which is the correct answer, right? So I thought you might need a little bit of extra help here with getting the probabilities for these kinds of things so you can actually eventually find out your total expected values there. I think the formula here is pretty good. Rewatch this if you need to. This one was a little bit tricky just because it throws in the binomial distribution kind of to start with, but it's good to start reviewing kind of some of these things.